Hi, everybody. Thanks for joining in. We'll get started here in a couple of minutes. So give it another minute or so, and then we'll get started. Thanks for joining in. All right, everybody, thanks for joining in. I'm going to go ahead and share my screen. So you should be seeing the course homepage. Could somebody kindly unmute and let me know if you're seeing that?
Yes, ma'am, we are.
Thank you. All right, so just as a reminder, this is being recorded, and I will post the recording in the announcements in a day or so once I get the captioning going for it. I have been posting the videos in the announcements, so you can go back and look at them at any point if you need to. And I've posted some announcements, regarding the discussions. If you hadn't taken a look at those, you might want to go out and do that. All right. So here we are already in week 8. So we're literally halfway done with this course. And this week we're dealing with gravitation. And so here's the gravitation overview. Sorry, everybody, I had to mute for a moment. My puppy was kind of barking. So here you see listed the objectives for our unit on gravitation. And so you're going to be completing an experiment, and the whole goal is to help you to be more familiar with the law of gravitation, the formula, what the variables in the formula mean. And of course, in lecture class, we talked about the relationship between uniform circular motion and gravitation. You'll also be seeing some of that in this experiment that you have to complete. And it will require that you, the experiment and some of the questions that you'll come across in the handout and the discussion will involve using the formula to actually, calculate some things. The goal here is to give you more exposure, to give you, opportunity to get familiar with gravitation through utilizing a simulation, right? That's how we typically approach this since we're in an online lab environment. So you do have some items on your plate between now and Saturday. And we'll take a look at the experiment that you have to complete. We'll look at the lab report that you have to write, and I'll talk about the discussion that you have to complete. And of course, I always provide to you the instructions on how you turn in lab reports, which by now, you know, basically you email me your items, except for the discussions as you post your responses in the discussion forum. And then of course, if you have any questions while you're working, you can always reach out to me through the class questions forum or email, office hours, however you like to approach getting your question answered. And I have made some materials available to you regarding this topic. The chapters in the CK12 textbook that we use in lecture that relate to gravitation, those chapters are linked to here for you. There are some videos and some other information available to help you in the event you are, you know, having to refresh yourself on gravitation. So my suggestion is to students is always go out and take a look at these reading materials and the videos first, and then come back and attempt the experiment, because that way the you know, the background will be fresh in your mind when you go to do the experiment. Okay, any questions on that? All right, so let's take a look at the experiment handout. And just move this out the way and make that full screen. Okay, so let me just zoom in a little bit. The print seems a little bit small there. All right, so as with everything, I always provide you relevant objectives for completing this activity. And then there is some background given here. And in fact, I talked about some of these things in lecture class. In particular, you know, I talked about the background of how Newton, you know, theorized and formulated the relationships that are part of the gravitation formula, which you see listed in the first box. Okay, so you can see the relationship between the masses of the objects and the distance between them. And then it talks about the fact that Henry Cavendish came along and, you know, experimentally confirmed the relationships that Isaac Newton had figured out. But in addition, he helped us to get the value for the gravitation constant, the big G that you see listed in the formula. And that's one of the things you'll be trying as you work through this experiment. And then in the middle, you see that's Newton's second law of motion, force equals mass times acceleration, except they've written the formula for centripetal acceleration, because if you're dealing with gravitation, then we have to take into account that it is the centripetal force that is being provided by the gravitation force. In fact, those two forces, F and Fc, are equal to each other. And then the other thing we have to rely on is our knowledge of circular motion, where the centripetal acceleration is found by taking the speed squared divided by the orbit radius, or the distance. That R in the formula is equivalent to the D in the first formula. Okay, so you're going to be using those formulas as you work through this simulation and the experiment handout. So let's take a look at the simulator, and then what I'll do is come back and we'll look at, you know, what you need to do with the simulator to complete the experiment handout. So this simulator is much like many of the others that you used, because it works right in the browser. You just only have to hit the play button and it opens up. and then you can make adjustments. So you see you have your M1 and M2, the same, let's see if I can blow this up, have this up on the screen. So you see in this formula, the M1 and M2 and the distance. So when you go into the simulator, that is the M1 and M2, okay? And then you can manipulate distance by sliding them, dropping and dragging them closer or further apart. You can change the mass by, you know, individually by one, or you can, okay? Now, I like to put it in scientific notation because that makes a little bit more sense to me than that long decimal out notation. And what is readily evident when you put it in scientific notation, if you notice that it calculates the force for you. So you tell it M1 and M2, and it calculates the gravitation force between the objects. And remember, this is an attractive force. So gravity is an attractive force between two objects. And so the reason that the arrow on M1 is pointing to the right is because M2 is pulling object 1 to the right. And the reason that the arrow on M2 is pointing to the left is because M1 is pulling M2 to the left. So those two forces are attractive and they're the same size, but they point in opposite directions. And so by manipulating the mass and the distance, you can see how that force changes, okay? And that's the whole point. If you're looking at the gravitation formula, the whole point is, if you know the masses and the distance, you can combine that with the gravitation constant and figure out the force. Well, it calculates the force for you. You only have to tell it M1 and M2, the distance, it figures out F for you, okay? So are there any questions on the simulator itself? Because it's pretty straightforward to use, but I want to make sure that you don't have any questions on using it. Any questions? All right, that's pretty straightforward. And in fact, I don't recall, but there may be some type of activity in the lecture where you'll also use the simulator, but you won't be figuring out the same thing. You might be using it in lecture to do something different, but in any event, it's a great visual tool. All right. So now this experiment is sometimes a bit challenging to students. So if you have questions, please don't hesitate. Now it tells you here to hit the big red 5, but they've gone in and modified so that as soon as you click on a link, you don't see the red 5 anymore. So I haven't had time to go back and modify all the experiment handouts to take that out of there. But when you click on a link, just hit the play button. And that's how you open the simulator. There is no big red 5 anymore. And I might go in and yeah, I'll go in and modify those, but you know, I just haven't got to it for this experiment as of yet, because some of these changes I didn't know about until just recently. Okay, so click the link, hit the play button, the simulator launches, and then you can adjust the values and you know, get familiar with it. And then what you're going to do is, in step 2, you're going to complete the chart. Okay, the chart has 8 different values that you have to calculate. So the question then becomes, how do you calculate it? Because what they're asking you to do is, if you use the mass, the distance, and the force that the simulator gives, what is the value of the gravitation constant? And you have to do that each time you change the mass, each time you change the distance. And so what you're going to be doing is completing the chart by solving for G. Solving for G. Now, let's look at how we solve for G, because I put that there for you as well, because I knew that some students would have a challenge with that. So I gave you a handout solving for G. Oh, let's see, maybe I didn't. I need to add it for you. Bear with me for a second, because I want to make sure that you have access to that. I did think maybe I put it in this class and forgot to put it in yours. Let's see. I do apologize. Let's see if we got it in here, and I'll make sure you have access to it. Ah, so no. Let's see. Maybe I have it in the files and I just haven't linked to it. Let's see. Yeah. Okay. Bear with me just for a second. I'm gonna go and get a copy of that handout. And I'll make sure you have it available. That's my oversight on that. Let's see. Okay, let's see. Oh, well. Let's see if I can get that. Maybe I'll put it in here. I do apologize, but I don't want to move forward until I actually show this to you. So. Let me see. Is this the handout? No. It. Okay. Well, we can do it the old-fashioned way, and I'll make sure you have access to the handout. Let me just open up a whiteboard. All right. So we'll start from here with the formula. So I'll start with it as written. So F equals big G M1 times M2 over, and I'll keep it in the format that they have it, D squared. It could be D squared or R squared. It means the same thing. But remember, you're getting F from the simulator. So the values that you have given, okay? So you're given the values F, M1, M2, and D. Oh, that's not good. Okay. And D. Okay. And you need to find big G. Okay. So now I normally try to, stay away from a lot of algebra with you because I recognize that could be a challenge. So the way you're going to find G is by using this formula. So big G is equal to F times D squared divided by M1 times M2. Okay, so that I always put the parentheses here to kind of highlight the fact that, you know, how things are grouped. All right. And when you find that value for G, it is going to, well, it'll have, these are units, Newton, meter, oh, that's ugly. Newton meter squared per kilogram. Squared. Okay, these are the units. So the units, okay. Oof, wow, okay. Units for big G, okay? So when they ask you to fill in the experiment handout by calculating, let me go back to the experiment handout now that I've kind of put that on the, okay. When they ask you in the handout to complete the column by solving for G, that's the process that you have to go through. You have to use that formula. So every time you change the mass, you change the distance, it calculates the force, and then you use this formula to calculate big G. And you have to do that 8 different times to complete the table, okay? I apologize for not being able to put my hand on the actual whiteboard printout that I did before, but do any of you have questions on how you're gonna find G to put in the table for the experiment handout? Okay, so in step 3, you're gonna use that formula 8 different times and complete the table. Does that make sense to everybody?
Yes, ma'am.
Okay, and then it asks you for an average value for G. So if you have 8 different values, the way you get the average is to add them all up and divide by 8. That makes sense, hopefully, to get an average. It asks for the units for G. Well, I just showed you that on the whiteboard, right? I showed you the units for G. And it asks you also the published value for G. Now, the published value for G is what is the correct value for G is what they're asking you, okay? The published value for G means what is the correct value, or, you know, if you looked it up in a textbook, what would be the value that you find? Now, those of you who have me for lecture class, we covered that value on Monday. So you have actually the correct value for big G listed in the lecture notes. And of course, if you use any of the reading material that I provided, you're gonna find the value for big G. And then it asks you your source. Where did you find this published value for big G? Okay, if you use my notes, just put Dr. Z's notes. If you found it on Google, wherever you found it at, okay? And then the last question there, how did your value of big G compare to the published value you found? What they are asking you to do in that step is a percent error calculation. So you are comparing your average value to the published value, okay? In that step where it asks you, how did your value of big G compare to the published value? You are doing a percent error calculation to compare your average value to the published value. Okay, I want to make sure everybody understand that, because a lot of times students, when it asks how did it compare, it says, oh, my value, some students write, oh, my value was bigger than it, or my value was, smaller than. It's not asking you that. It's asking you to do a percent error calculation. Anytime you're asked to compare two values in this class, they're asking you to do a percent error calculation. And if you recall percent error, whenever you do a percent error calculation, you have to have an experiment value and a correct value, right? Your value and the correct value. Well, your value is the average and the correct value is the published value, right? Does everybody understand that? Okay. I didn't get
Yes.
any questions. Thank you. I didn't get a question, so I figured that must be clear. And then beyond that, everything else is just to use the simulator to answer the question. So there are total of 16 questions. You're going to use the simulator and any formulas that you might need to fill in the blanks or answer the questions. So that's the experiment handout. Complete the table and answer the 16 questions using the simulator. All right. All right. So once you've completed the experiment handout, then you know the drill by now. Your next step is to do what? Write the lab report, right? So then you're going to go and write the lab report, and no mystery here, because this is the same kind of lab report you've been doing. This is the same format you've been following all along. So remember, in your abstract, you have to be detailed. You have to explain the procedure that you follow. And please don't say, I used the simulator that the teacher gave me. Please explain what you had to do to make the simulator function. And then make sure that you give the website that you use for the simulator, right? Because if you don't give the website, then somebody looking at your abstract wouldn't know what website to use. And then explain, in your words, what was the purpose for doing this experiment? And then what you found. So under what you found, remember, what you're doing is you're talking about, hey, I noticed when using the simulator, as I made the distance bigger, this happened to the force, or as I made the mass smaller, this happened to, something that you figured out about the values, how the values change as you use the simulator. And then you also have a percent error calculation. So for example, if you calculate the percent error between your average and the published value for big G, and your percent error is large, then what does that mean to you? Or if it's small, what does that mean to you, right? So under what you found, because you have both of these things going on during the experiment, you have to discuss both, all right? You have to discuss your percent error and something that you figured out about how the values change as you manipulate or operate the simulator. And then your data and analysis is the completed experiment handout. There are some people who are turning in the abstract and the conclusion and not the experiment handout. Well, you're losing a large number of points because the experiment handout is your data and analysis. How are you going to have a conclusion without data and analysis? Okay. And then the conclusion, remember, your task is to tell me what you learned, right? So tell me something that you learned about gravitation that you didn't know when you started, okay? Any questions about what goes in the lab report? Okay, all right. So after you've completed the lab report, then the next thing is to complete the post-lab discussion, right? So in this post-lab discussion, you have some questions that you have to answer first, and then you have to respond to your classmates' postings, 2 of your classmates' posting. All right. Now, this one does actually require that you solve some problems. That second one is going to get you to use the formula to solve. And so, you know, you want to be thorough when you solve. Okay. And then after you've posted your complete answers to those 3 questions, and go and critique and communicate with your classmates, at least 2 of your classmates. All right. So any questions on the simulator? Any questions on what you're going to do to complete the experiment handout, primarily how you use this formula for big G, which I will make sure you have a copy of in the activities and assignments. I'll put this information for you. I apologize for not having that before we started, but any questions about this particular formula for finding G? All right. Any questions about the lab report that you have to write? Any questions about the post-lab discussion? All right, so while you're working, you know, working on completing these items by Saturday, if you have questions, please don't hesitate to reach out to me. I'm more than happy to address your question. I just, you know, I just need you to reach out and ask them, okay? Anything else that I can discuss for you? Any other questions that you might have? All right, so I'm going to stop the share. And again, I thank you for joining in this afternoon. I know it's always a small crowd, but you know, diligence pays off, right? I'm glad you're here and can ask any questions that you have in person. So if you don't have any questions for me, we're all done. If you have something and you want to hang around, don't hesitate. I'll be here for a minute.
I have a question. It's kind of way off topic, but I saw that we have like a final exam. What is that gonna be like? Like, is that gonna be like a lab experiment kind of?
You can actually go into the final exam weekly overview, and you can actually look at all the information on the final exam. The only thing you can't do is take the actual exam.
Okay, thank you.
Yeah, so like the you know, what's going to be on the final exam, all of that stuff is provided in that weekly overview.
Okay, sounds good. Thank you.
Yeah, so if you take a look at it and you have some more questions after that, just shoot me an email. I'll be happy to address any questions once you've taken a look.
Will do.
All right, now
Have a good day.
you do the same.